Welcome to another episode of Monday Bible. I'm your host, Michał Jackowski, and today we have a very special guest with us, Harry Surden. Harry is a professor of law at the University of Colorado, specializing in the intersection of law and technology, particularly in areas such as artificial intelligence and computable law. Associate Director of Stanford's Codex, esteemed author and speaker. Today we'll be diving into his groundbreaking works on recent advancements in AI and their impact on the legal field. Harry, welcome to the show.
Thank you. It's an honor to be here.
I read recently your last two papers. One of them was part of Cambridge Handbook of Private Law and AI on Computable Law. It presents a fascinating overview of how legal obligations can be translated into data. Could you briefly explain what computable law is and its significance to lawyers?
Absolutely. I think it's helpful to provide a little bit of background to some of the listeners who might not understand various aspects or be familiar with various aspects of computer science. I have a computer science background in addition to a law background. So one way of thinking about computer science, particularly AI, or there's sort of two distinct approaches. One approach, which is associated with what's known as knowledge representation, involves having experts manually create rules or models of real-world processes, whether it's the law or medicine or mathematics. And this has been a very successful enterprise for many years, and indeed is the underlying process by which we see most computer programming today. Most computer programs, whether it's Microsoft Word or web browsers, were created by programmers who manually modeled various aspects and processes. There's a different approach, which we'll talk about a little bit later, called machine learning, where the computer itself discovers patterns in data and comes up with the rules on its own, and it has its own strengths and benefits. So computable law is more in the first category, the category of looking around the world and having experts along with computer programmers make models of particular things. And a model is a simplification that is useful, but also has various structure that a computer can use. So in the case of computable law, we're modeling various aspects of legal obligations. These legal obligations can either be things like legislative rules, what we normally refer to as law or statutes, or in some cases it can be things like private obligations, contracts, or obligations or doctrines produced by judges. So one of the interesting aspects of law is, for hundreds of years, law has used this technology, which is ordinary language. We call it in computer science natural language. And this has been extremely useful. We have, for example, in the United States, we have our laws written in English, our contracts are written in English, and one lawyer writes it and another lawyer reads it, and that's very useful. But in the last, 50 years or so, we've had computers, and computers are not as good traditionally at people at reading natural language, particularly with the precision required by law. So computable law is this intermediate process where we either have human experts look around at legal obligations and kind of translate them into forms that computers can easily process. Interestingly, and we'll talk about large language models like ChatGPT in a little bit, these days actually you can harness computers to do the translating themselves. So computers like large language models can translate natural language laws or contracts and translate them into ways that the computers themselves can more easily process, which is a fascinating development of only the last 2 years. It wasn't previously possible. And when you create this computable law, it brings all sorts of benefits in terms of data processing. You can do really interesting applications with the law. You can ask computers questions about the law that humans can't possibly do just by reading ordinary text, questions about across tens of thousands of contracts. A computer can give you answers about obligations or things of that nature in ways that a human reading, 10,000 written documents can't quite do.
This what you mentioned. You also discuss in your paper two approaches to creating computable law: translating traditional legal text into data, and expressing legal obligations as data from the start. It's involving all these computers, machines, robots into a legal system. Could you elaborate on these approaches and their practical implications?
Yeah, absolutely. So it's interesting. The traditional approach, given the long history of law, has been to write something out in natural language like English, French, Spanish, what have you, and then later on have somebody else translate it into some computer programming language like Python or computer logic. There's been an interesting different development, which is what we call data native laws, where the law is expressed as in computer programming language first, and then in some human understandable form second. And both are, reasonable ways to go about it. One of the most interesting aspects, though, for law, because law is primarily to govern people, is there almost always has to be some human readable aspect to it in addition to a computer readable aspect. So you wind up having kind of these two versions of laws these days, the human readable aspect and the computer readable aspect, and they have to pretty much correspond to one another. So what we're kind of doing is making this link explicit between the human readable aspect and the computer readable aspect, which until recently has been implicit. So what do I mean by that? Well, we're in the modern computer age. For the last 30 or so years, we've had the internet, and people have been doing this, but only kind of in the background. So you have somebody who writes a writes a contract, say in finance. They write it in ordinary natural language by a lawyer. Some other lawyer reads it, and then it gets sent to some back office somewhere where professionals have to read these contracts and then translate them into the computer programs that run the business, whether it's Excel, very often it's Microsoft Excel, or sometimes it's kind of these enterprise management systems. But these are the systems that actually, if you if your contract says we need to buy 10 widgets for $100, somebody's going to actually find the widgets in a warehouse somewhere, send it out, move the money around. All that has to happen in the real world. So this back office is kind of an implicit or in the background translation of the contract in a way that some computer system can understand. So this is already happening in the background. We already have this kind of shadow version of the contract in the English. So we're trying to make this more explicit by saying, here's the official computer version, here's the official natural language version of the obligation, and we're going to link them up so that we can inspect it and make sure that those two things come up rather than having it exist implicitly in the background.
Do you think we lawyers are ready for such the change with our knowledge or level of knowledge of data science? You teach AI and law. I do a little bit of the same, but majority of lawyers do not know what annotating is or what machine learning or natural language processing means. When can we be ready for this step?
Yeah, this is a great question. So I would say the answer is no, we lawyers are not ready. But fortunately, we don't have to be because a lot of those complexities get hidden from us. So the way a lot of these, so let me give you an analogy. If you've ever bought something on Amazon, for example, or some sort of online platform, you click some button saying I want one quantity of this item and I want it shipped to my house. So you're clicking buttons, but that is really a contract. And in the background, unbeknownst to you, these sort of computable contracts are being created between you and Amazon and the shipper. So what's going on there, and this is an important invention, is that the what we call the user interface is being controlled in such a way that the user, the buyer, really doesn't have to pay attention to the details of what's going on in the background because they're not. For example, let me contrast. Say you were typing up a contract with Amazon to send you a widget in Microsoft Word. you might have to type out, I agree that Amazon will send me one widget for $100, and then you'd mail it to them and they'd send it back, right? But in our modern world, because we're transacting through a computer on the web, you can control the interface such that you're clicking little buttons that indicate the quantity and what you're doing. So all those details are being specified and controlled through the interface, the address, all that's in structured data. So when you hit buy, all that data is being precisely collected in structured form that can be captured in a contract and a computable possible contract and sent off. So that's a lot what we're doing. I work at a center at Stanford, and we work on computable contracts. And a lot of what we do is make contracts invisibly structured in the process. So the lawyers are no longer typing up the contracts in Microsoft Word. They're building the contracts through a computer interface, and the data is being created in the background invisibly. So they don't really need to know computer science. They just need to use this different interface when it's appropriate.
So as our role is decreased in contracting, at least, maybe AI can support us somehow in other tasks, in other areas. What you've had recently a speech in London about AI's impact on law, and do you think AI can truly support lawyers in their work?
Absolutely. I think so. Today, we've had a lot of advances in large language models, which I'm happy to talk about, like ChatGPT or Claude from Anthropic. These are frontier large language models, which really only since 2022 have they gotten good. So I've been studying this for a long time. And for many years, they were interesting, but not useful. They were pretty bad. And they've recently started getting good and useful, and they're only getting more useful. However, you really have to understand what they're good at and what they're bad at, and understand their limitations. Because if a lawyer doesn't quite understand the limitations, they could be sort of misled into using them incorrectly. But I really do believe that for a lot of functions, it can be quite useful for lawyers. So I'll give just a few examples. And I want to stress that it's really important to use the most advanced AI models and give them the best information, and that's how you get the best results. So one of the best use cases of large language models today is understanding documents. So in law, we have a lot of documents, and a document can be anything from a legal motion, a brief, a court opinion from the past. It could be a law review article by a law professor. These things are complicated, and they're long, and they often have details, and they're often hard to understand. These large language models are excellent at summarizing documents quite accurately. And then what's really interesting is that you can interact with the documents. You can ask questions about clarifying questions. So in the past, if you had a long law review article from a law professor that, I write these things, these things are impenetrable, they're not understandable. So you just have this document there that you were stuck not understanding. Now you can ask questions and clarify your understanding thanks to the large language model. So it's really leading enhancements in lawyer understanding of legal documents. So this is probably the highest and best use of current models today in law, is the summarization and enhanced understanding of complicated documents. But there are also other ways in which these large language models can be used, provided that you give them the right context, as they get the right information, the right legal background. Right now, it requires a little bit of manual curation, but they can answer what I call legal easy cases. These are cases that lawyers would agree on the answer, and there are quite a lot of these in law, but maybe a non-lawyer wouldn't have the background knowledge or analysis in law to understand. So we can think of it in law as a range of kind of legal situations that lawyers deal with. A lot of what lawyers deal with are hard cases where the lawyers, using their intense legal background, making judgments in environments of uncertainty, doing kind of unique, bespoke transactions. But that's not all of law. In fact, a lot of law is kind of routine stuff that lawyers know the answers to, but non-lawyers really don't because it's so complicated. These large language models are actually quite good at answering legal questions really well if you give them the right information. So, for instance, if you have a US copyright question, if you give it the relevant copyright information in the prompt, or if you use one of these specialized legal large language models like Lexis plus AI or Westlaw Co-Counsel, which grabs the right information automatically in the background. Once it has the right rules, it can answer basic questions very accurately. And this is a really new development in law. We've never really seen AI systems that can help lawyers to this extent. But the key is understanding when they're able to make kind of routine judgments and when something's a little more complex and you can't rely on the large language model because it will give you an answer regardless. But in the more complicated situations, you don't want to rely on its answer.
So we'll discuss the limitations in a minute, but I wonder if you think if large language models like GPT-4.0 or Cloud 3.5 are now ready to be used as legal AI, or we still need some traditional machine learning methods as like knowledge bases or formal systems supporting or cooperating with LLMs. What do you think? Are we close
Yeah,
to artificial general intelligence applicable to law or not yet?
yeah, that's a great question. And before I answer that, I just want to emphasize for your uh, listeners who might not be familiar, connecting the distinction between computable law, which we talked about earlier, which is creating structured models of law using experts and computer scientists, versus what we're talking about here in large language models. In large language models, they go out and they use statistics and probability and basically read all the law and all the web and come up with their own rules. So it's an entirely different but equally useful approach to the structured form that we talked about earlier. Both approaches are very useful. Structured, curated data, as well as statistical approaches embodied by machine learning. So so that was a great question you asked. Like, is it ready for prime time? I would say yes, with a big caveat being there's not a high degree of AI literacy among lawyers, legal officials, and judges. So if you were somebody like you or me who very much understands the strengths and limits of these technologies, they can be incredibly useful, and they do actually have the knowledge and reasoning base, if properly used, to give terrific answers. That said, that is not the state of the systems out there in the world. It's kind of like maybe the early days of the internet and Wikipedia, where Wikipedia had some good content if you knew what to look for, and it had some bad content, and you really needed a lot of background knowledge to use these systems correctly. So I think we're not quite there yet in the sense that we would want to give this over to somebody without a deep understanding of limitations, because these systems present themselves as if they're giving you always correct, confident answers. But sophisticated users know that's not the case. You have to properly use them with the background information. However, I think we're close to it. A lot of these sort of composite systems that we're seeing are trying to take away some of these error points that lawyers could accidentally find themselves in by taking away those, like right now, a lot of it depends on what sort of prompting you do. If you can do good prompts or bad prompts, you include a lot of that, those details are going to be taken away from the user in coming years to lessen the ability of not less sophisticated users causing their own mistakes accidentally. So I think we're at that point where I would say, unless you're an expert user in this, be very careful. However, the technology is actually there under the hood. It just requires, there's lots of ways in which it can go wrong if not used correctly. There's sort of a distinct question you asked with respect to AGI. So AGI is not very well defined. There is lots of different definitions, but I would say it's something like, can the computer do any arbitrary knowledge task at the level that meets or surpasses a human? My honest answer is I don't know. I think we're seeing steps towards it, but it could be 5 years, it could be 20 years, it could be never. I would make a distinction between AGI and what we're seeing today, which are useful AI systems, generally useful, right? So this is only since 2022. I want to emphasize that we've seen systems that are now broadly useful for humans. Before they were narrow and often not useful at all. So what we're seeing are tools that are genuinely useful to enhance human decision making and analysis, as distinct from AGI, which I don't really know the answer to that. I feel like we can only see how the technology is going to develop.
I was really interested in your point of view on AGI. I know it's not well defined, and we have a lot of disputes about it. But as you mentioned, the technology is almost ready. Thank you. Goodbye, our listeners. Stay tuned for the next Monday Beagle episode. See you.